The interstellar object, Atlas, the third visitor from outside the solar system ever discovered, is currently near its conjunction with the Sun, completely hidden from our telescopes. On October 21, Atlas moved to a position perfectly opposite the Sun from Earth, becoming invisible to all human observing systems. On October 29, it will reach perihelion, the closest it has ever come to the Sun in its orbit. At this point, a powerful 33 gigawatts of solar radiation will hit Atlas's surface. To put that in perspective, that's the equivalent of 1/3 of the total power generated by all the nuclear reactors in the United States, all concentrated into a single object about 35 astronomical units away. It's the most powerful moment in Atlas's multi-million-year journey through interstellar space. So what makes this event so remarkable? If there are any unusual physical processes happening, massive ice sublimation, complex chemical reactions, or even unimaginable phenomena, it's happening now when we can't see them. This is the only time this object has ever passed through solar maximum, and the strange thing is that we can't see any changes. The big question is, why did this object, with all its anomalies, pass through the peak energy point at a time when all other means of observation were blind? Is this a coincidence, or is there something more mysterious going on that we can't explain? With every minute that passes, Atlas continues to move through the solar system, and we are missing out on direct observations of what might be happening on its surface. Events like these not only challenge our current understanding of the universe, but also open up new, challenging possibilities about the origin and nature of this object. What will happen when Atlas reaches perihelion in the coming hours? And could this event completely change the way we understand the universe? We certainly won't have answers right away, but the coming days will be an exciting time as all sorts of hypotheses become reality. Atlas is systematically breaking every established pattern for interstellar objects. Since its discovery, it has accumulated a series of features, each of which can be explained individually, but together they form an unprecedented scientific puzzle. And this puzzle is no small one. It could completely change the way we understand the universe and interstellar objects. The first anomaly that scientists noticed was the unimaginable orbital arrangement. Atlas's orbit is only 5 degrees off the ecliptic plane where all the planets orbit the Sun. For an object from interstellar space, the chance of this happening by chance is only 0, Baffinger R. This is not only a statistical curiosity, but also the ideal trajectory if the goal is to reach the planets in the solar system with minimal energy consumption. If you were designing a mission to explore Mars, Venus, Earth, and Jupiter in a single flyby of the solar system, you would choose exactly this path. Atlas's orbit maximizes the chances of planetary flybys while minimizing the necessary course corrections. The second anomaly is an unlikely chemical finding from the Keck 2 spectroscopic data. Atlas is emitting nickel at a rate never before seen in a natural comet. On Earth, this characteristic only occurs in tightly controlled industrial processes, specifically in the production of alloys through the carbonyl process. The nickel is concentrated in a region of 600 kilometers around the Atlas nucleus, while cyanide, the other compound detected, spreads out to 840 kilometers. What's surprising is that if both compounds sublimated naturally from ice, they would follow similar patterns based on volatility and solar heating. But Atlas doesn't. The copper-nickel in Atlas behaves as if it were part of an organized structure, not a random sublimation from a dirty snowball. This raises a big question. Is this a sign that Atlas isn't a natural object? The third anomaly was a revolutionary finding. Atlas is only 4% water by mass. This was extremely surprising because comets are known as dirty ice balls in which water should be a major component. Comet Borisov, a previous interstellar object that everyone agreed was natural, had a typical water composition. So why was Atlas so fundamentally different? Even more interesting, the polarization of light reflected by Atlas was extremely negative, a phenomenon never seen in known comets, including Borisov. This suggested that Atlas's surface or structure might be unique, a sign that the object was more than just a natural comet. The fourth anomaly is Atlas's extraordinary mass and size. The object is estimated to weigh 33 billion tons, 1,000 times more massive than Comet Borisov, and 1,000,000 times more massive than Oumuamua. At least 5 kilometers in diameter, Atlas has enough mass to carry significant payloads across